right, it's the Weather Wise guys, meteorologist Evan Chickbear, and
Hey, I'm Wes. You can just call me Wes, or meteorologist Wes. Period. Whatever you want.
sure, we're just Evan, just Wes, we're Wise guys. I really enjoyed last week. I thought I had never talked about birds like that much. I don't think at any point in my life, and we spent like an hour talking about and laughing about birds with meteorologist Eric DeBroca. So that was fun. I genuinely enjoyed that.
Yeah, he's just kind of like a funny guy and like really interesting in general to talk to. Whenever you first said, hey, I got like a bird expert I'm going to bring on, I was like, oh, so we got some, I forget the name of like what a bird expert is. Like, it's not ornithology or like not ophthalmologist. You know what I'm saying? I thought it was like,
I know there's a word for it. I couldn't tell you what it is, but
yeah, ornithologist, I think is what it is. I thought we had like an ornithologist. It's like, no, it's my buddy Eric. He has a bird. Like, all right, cool. That's it. And then, but like, he was super interesting. He knew like a ton about it. And so, if you haven't watched that episode,
it, it's good.
yeah,
You
yeah,
don't necessarily have to have an interest. Like he made it fascinating and funny. And I had a couple emails from people here that watched. So that's what we try to do. We just try to have fun. Teach you something. We learn something. I still go back to Grady Dixon, who we had over the summer, and I have used his data that he's given, and I've been able to share that with people when I go to these visits and stuff. And it's that's the whole point of doing all this, is to learn something, maybe pass it around, and not put out any dumb nonsense that we see constantly. So here's the docket today, Wes. What do you think?
Well, speaking of constantly learning, we never learned about space weather in depth in school. We mostly sticked with like, the Earth. Well, I took a planetary geology class. I think you did too.
Yep.
We like briefly touched on the auroras and stuff like that, but I mean, to the level in which maybe we should or need to know about space weather and how it goes, we just never got any formal education on that.
So the way I explain it to people is we do a lot or a little bit of everything, but a lot of just, one thing. We really focus on the atmosphere and its function and the physics behind it. But we have a touch of everything else, of the solar system, of space, of how things work in that realm. And so it all kind of ties together. So, yeah, I'm with you. I'm no expert on, there's way smarter people, but the general idea, we can explain the solar wind and how it interacts with the poles and gives us these lights. But before we do all that, I'm sure you can find somebody with a doctor title or PhD who could explain better. But we'll try to make some sense of it. Did you see any personally, Wes?
Not like with my bare eyes. I saw it like in pictures. I went out on our roof, and I'm like in the middle of the city, and I was able to see the faint pink glow off to the north. Our weather cameras caught it, and again, like are in the city. And I was actually watching the greens and the red dance, and I was in awe. Like that was like some of the biggest FOMO I've ever had in my career, in which like something you only see in the upper Midwest happening over the city was just mind blowing, and it still is to me.
I'm in the similar boat as you because of how everything lined up. Now, the only thing that bummed me out, so right before the 10 o'clock newscast, these are pouring in.
Oh
So
yeah,
I stopped what I'm doing because this was also the same day that we were coming off of the record lows here. So not only are we seeing the dang auroras, it felt like we was in, Winnipeg or somewhere up in the Arctic Circle. And, I'm seeing this in central Alabama, which we're a good ways south of you, Wes, and we don't
yeah.
typically see that stuff, but the pictures that we'll show are really cool. And I did not realize at the time that there was going to be this big geomagnetic storm and a big flare-up that was going to provide this. So I was kind of like taking it all in as it went, but a little jealous we didn't see it on our sky cams. I was jumping around to the ones that had the least light pollution. I couldn't find any.
I had a pretty good indication that something could happen. I've had to deal with the aurora probably a little bit more frequently than you because I'm further off to the north. Last year we had a couple, maybe 3 instances of strong solar storms, and we saw like very minor showings here. And for all the shows, I was like, hey, we might see it. Don't know if it will, but like, there's a very good chance that we could see it. Go outside after this time, go look, blah 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 blah. And yeah, once like 7 o'clock hit, everything just started flowing in. Like it got dark enough, everybody was looking outside, and it was just like hours of photos of posting and everything like that. But I still did learn a lot from that event in terms of like prediction and how to try to communicate things properly. But I mean, we're not astrophysicists, so I have to rely on. I know you do too. We have to rely on reliable sources that can communicate this properly, and so then we can try to communicate this with the general public on our like streams of social media, on air, everything like that.
Yeah, and that's one of the things that too I feel like we try to make very clear is like we're a vessel, where there's a lot. I say this, and my wife's like, "Why do you say that?" I said, "Because it's true." Go places. I said, "There's a lot of people that are far more intelligent, a lot smarter than me in this field, that could tell you more. But I'm good at delivering that or passing that on. And we understand weather and the science in general, but this gives us a unique opportunity to pass that on or be part of it, and that's pretty cool. So you mentioned where you are at relative to me. So you want to start there, Wes, and like why the higher latitudes are more likely, to see the lights. Why is it closer to the poles? I can let you start this, or I can.
Yeah. No,
Just
go
let
ahead.
me.
Go ahead and rip out the barren graphics. Let's see what we got here. But I mean, generally, I'm closer to the North Magnetic Pole, so I have a better chance of seeing these kinds of things. I equated this to like what happened if someone in Miami saw a flurrying. That is how like insane this is. Like if you were to talk to someone in North Dakota, Minnesota, Alaska about seeing the aurora, they're like, okay, like yes, like that's not that big of a deal. But I mean, for Kansas and Missouri, and certainly for you down in Alabama, this is like an incredibly rare, once in a lifetime event. I say that, but like two two times last year we kind of saw it, but this one was much more vivid. So you're closer to the pole, magnetic pole, and so they're getting more interaction with the magnetosphere and the plasma that was shot off from the sun. And there's always like particles coming off of the sun interacting with the solar wind. So there's always like the solar wind, just like there's always wind outside in general. Sometimes there's storms, and so we got a solar storm. But since even when there's wind and smaller storms, those interact with the Earth's magnetic field, which is stronger up to the northern magnetic pole. And so people in Alaska and Canada see it more often. But the storms have to be really strong, amongst other things that have to come together, as far as I understand, for the aurora to be visible down south. I learned, Evan, that like, did you know the Earth's north magnetic pole can be pointed north or south? And if it's pointed north, like things don't come together to see the aurora. But if it's pointed south, then it comes together and it has to be a certain strength. Like
Wow.
every single time we get one of these events, I like learn something small.
Yeah, I there was 2024. Do you remember what month that was? There was another big
I want to say
like
March or May.
I was going to guess May, but it all kind of blends together. I learned so much from that just by listening to other people. And again, I understand the idea of these solar storms, these flares. They're usually on about 11-year cycles where they really pick up. And but hearing some of the finer details about why the color change, why so far south. I mean, the intensity of, because you're like, when I think of wind, I'm like, oh, there's a nice gust coming from the sun. Now, you can't see this. It's electromagnetic pulses. The sun emits all forms of energy on the spectrum. You can't see all of it, obviously, and it has some dangerous radiation it sends, but our atmosphere filters that out. Occasionally, like you mentioned, though, you've got this kind of electrical charged interaction, and man, does it give a show?
The really tough thing about this is that we are not very good at predicting it quite yet. So there's the exosphere. That's where, like the exosphere, I assume like the magnetosphere and then the ionosphere is up there.
Yeah, so like that's all lumped in. So it's the thermosphere. Once you get above there, you're basically you're 350 miles give or take from the surface, and all of that is kind of lumped into the exosphere. So that's where you have, a very small amount of particles floating about. They're highly energized. So when they interact with this solar wind, you get these vibrant colors. But it'd be equivalent to having me, you, and one other person running around on um, the field. What's the Chiefs field called?
Arrowhead Stadium.
Arrowhead. The three of us running around in all that space. That's like how many molecules are up there, but they're very highly charged, and so these interactions, that's when you're leaving the planet. So that's a very fascinating part of our atmospheric structure. But that's where those lights start.
They start, and then we can predict them somewhat. We, people smarter than me, predict them because we like are looking at the sun constantly, and we have like sensor satellites. I think one is like 1,000,000 miles between here and the sun, and we can look and see when these coronal mass ejections happen and giant flares happen, and so they can assess the strength of them, and then they try to guess the speed of them, and then they time that out with it hitting the Earth. But then there has to be so many things that like come together. Like if it misses the Earth, then like we don't get anything. If the magnetic field is pointed in the wrong direction, then we don't see the aurora. If the coronal mass ejection hits us in the middle of the day, we don't see it, but the dark side of the Earth could see it. And so essentially, it is like someone's in a boat and they have binoculars or they have like a telescope, and they're like, oh, there's a hurricane over there. Like there's a hurricane coming towards us. It's like, okay. Like then they do some calculations like, okay, there's a hurricane coming. I don't know if it's going to curve away from us and hit us, but like there's definitely a hurricane coming our way. That's kind of like what space weather prediction is right now, as far as I understand.
And interestingly enough, when you think about the flare, it sets things into motion. So one of the terrifying facts, space absolutely gives me anxiety. I can't think about the universe too much, or I just want to go like curl up in a ball. But once you start motion within space, there's nothing to stop it. So it's a big pulse of energy. So now you have this electromagnetic or this energy, this radiation coming from the sun, and depending on the strength of it, it might be a much stronger pulse. It's kind of like you take, and this is what I think of because our kids do math. You push the boat really hard. How far does it get? How
Mm-hmm.
fast does it get there? And when I see these plumes that are zoomed in of these solar flares, like okay, there that energy just went out to the atmosphere. Now we got to time it. We're 93 million miles away from the sun. How can these folks time it as well as they do? And they've been good. They give us these forecasts, and they're right in the ballpark. And it's pretty cool to see that the more and more technology we have, especially with telescopes and things being done with NASA, that we're able to know when this stuff's coming. Could you imagine like 100 years ago, all of a sudden the sky turns pink, and you're like, oh god, is it ending? Is it over?
I'm sure there is some sort of like folklore or some sort of like carvings in the side of a cave somewhere of people related. Just seeing some because like we are seeing it more often, partially because our phones have really good cameras
I
and can pick up on it.
that is something I have figured out too, because most people will send them to me and say, hey, I got this on my camera phone, but when I put it down, this was a big one last time in 2024, nobody could really see it with the naked eye, but if they put the
Mm-hmm.
phone up, they could. And I reached out to, there's a couple astrophotographers here who do a lot of space photography. They do drone sunsets and whatnot, and they said that there's settings that enhances greens, reds, purples within the lens, and our eyes don't see that. It's like what we talked about before with the colors that get filtered out. Why the sky's blue? Why it's a deeper blue in the winter when it's cold versus it's that sort of thing where our eyes don't pick
Okay.
up on it, but the camera in your phone will. So it'll bring that to light. So that was something else I did not know.
I don't know that either. I just I don't know that. I all I know is that you got to use the longest exposure possible to try and absorb so as much light as possible, so that what you can't see with the eye, you can see with your camera phone. And so that's like there's a bunch of reasons, just like we talked about with Grady. Like there's a lot of reasons why Tornado Valley. I don't know if it's fluctuating, it's shifting, like whatever you want to call it, is because like we're seeing it. Part of the reason is that we're witnessing it. We're able to detect it much better, like radar and camera phones. And this would be we have more satellites, we have more camera phone. There's just better communication overall. So there's a bunch of strong, we're not like a very active period in the solar cycle, like you mentioned, and we're able to observe it better. And so all those things work together to make this like maybe these are events that we didn't think were as rare, or these events we thought were rare were not actually as rare as they are.
Grady said something. Plain and simple, he goes, everybody has one. And you think about it, and just 50 years ago, we didn't have evolved radar. We didn't have satellites everywhere. We didn't have a way to see things immediately. This is a perfect opportunity to just say, when we see things happen in science and in weather, we don't have to get hyperbolic and think, oh my gosh, this is some sort of crazy change. Our sample size is so small. It is so small that over the grand scheme of how long our planet's been here and been functioning as basically an oasis in a deserted universe, at least to our knowledge. So what we're studying, every time something like this happens, it adds to the bank, it adds to the knowledge bank, and it gives us another resource. And Grady's explanation of Tornado Alley and Dixie Alley and why the numbers might be shifting, we're as simple as that. We're getting more information, we're getting more data, and we're making things each time we have an event, whatever it may be, it helps us learn more and more about it. So just because you see something happen doesn't mean it hasn't happened before. We just might, see it more readily because everything is spread like wildfire the second it happens. Like these pictures. Did your inbox crash?
My inbox got a ton. I mean, since I was posting pictures throughout the night, it was more so like my comment section on every single social media platform. People were just sharing their pictures on, which is great. Like, I very much appreciate that. And I like that because that gives me more stuff to post and more stuff to put on TV. And I'm all for the interaction. But I assume that is from Tuesday night.
Yes. So this was on the heels of our frontal system that went through. So I did wonder, and this is something I wasn't able to follow up with, is if our atmospheric conditions played any role in this, because we had a very, very cold air mass, very low atmosphere over us because we were at literally like the peak of a trough. And I honestly don't know if that plays a role in us being able to see it, but I know I was on air that night, and I know that the pictures that were coming through were absolutely insane. You can see the stars, Wes. The
Mm-hmm.
stars are visible through all of this,
Mm-hmm.
and they're not out like literally in the middle of nowhere. This isn't too far away from a small city. You can see it all from the distance. But I'm curious if the fact that it was a cold air mass, it was an atmosphere that was more dense. Did that play a role? I don't know that. I just was curious because it's just these pictures. I mean, there again with the stars. This is Hubbardville, Alabama. One of those astrophotographers. He sends me all sorts of stuff, but this was just unreal.
That's much better. That has like more of the pillars uh, to it, especially for like Tuesday. I'm glad you're able to see like the deeper colors than just like the little fuzzies that you couldn't see without a camera, essentially.
Yeah, it made me wish I was outside. Where we're at though is so populated. This is one of my
That's
favorite
good.
ones.
Yeah, that's
Um,
good.
it's so populated that outside of our station, like there's no way I could see it. I can't get to a good vantage point. But it blew my mind that everybody was seeing this. And, like I said, I've worked in Alabama now for almost 12 years. And this is the second time I've seen this happen to this extent. So, again, we're further south than you. Um, so it technically shouldn't be happening as frequently, but twice in what, 2 years? Pretty cool.
It's pretty good. What I have learned throughout this is that there are like magnetic lines of latitude, and instead of them being, or is it longitude? I think it's latitude around.
Latitude makes sense because the higher up you go, the closer to the poles. Changing latitude, yeah.
Those, so like when you're talking about like your lat long, those are perfectly symmetrical going around the Earth. The poles magnetic are different. They dip. They kind of dip from the northwest to the southeast. So they're not perfectly, and so like that's why maybe Alabama has a slightly better chance. Like northern Alabama has as good of a chance of seeing the aurora when these things happen as northern California does. Whenever you go and if you look at the Space Weather Prediction Center's like text products, they'll say, if the aurora strength reaches these levels, you can kind of see it right there, reaches these levels, then they could be possibly viewable across Northern California and Alabama. That bottom line doesn't really quite do its justice, but you get the general shape there
Yeah,
of what's happening. Like it's crazy to think that Northern California is so much further north than Northern Alabama, but from a magnetic standpoint, they're equal.
and when you think about the curvature of the Earth and everything, like it's something that you kind of have to process. But and this was one of the forecasts they put out. I think this may have been for Wednesday, so this was put out after that first one, or no, this was put out Thursday for Friday morning. So that line that's the furthest south, that actually ended up not being far enough south previously. Because again, as you mentioned, Wes, like some of this is very unpredictable. It's something we're learning about and we'll dial in. But nevertheless, that was a very cool thing to see. I was glad to see it through our viewers' eyes. I wish I could have seen it in person. That would have been pretty freaking awesome.
The people that know more about this than I do, we're starting to push back a little bit on the amount of maps that we're going out. Which I know you and I are making these maps like in good faith. But I started to kind of understand the frustration. And full disclosure, like Tuesday evening, I was showing a map, and that was based on like, okay, the forecast is of like this G level, this K level, according to the Space Weather Prediction Center, that brings the visible line down to this place. And I was like showing that. But those maps even like undersold how widespread it would be. Like if it's strong enough, I mean, the Everglades, like the Panhandle of Florida, like saw it, and like or Arizona and New Mexico saw it, and so it's like, man, if it's strong enough, the whole country can see it. Like there's no like real map.
There's not a true formula yet. There's no set rules. It's not like, oh, it can't snow at the equator. Which is also not true. I'm pretty sure there's high elevations. That was a terrible parallel, but yes, I thought the same thing. So our news director was like, we need to get an explainer in there, and I saw the graphics package, but I didn't necessarily know how to. I knew what that graphic that we used and was in Baron was showing, but I didn't feel like I could do it justice and explain why everything was going to be where it was compared to the folks who were putting this data out. You know what I mean? Like they're
Yeah,
the ones who have the knowledge, and then like we're passing it along. And I didn't want to do it incorrectly. I said, "Here's a potential for northern lights. I cannot tell you what these values mean, what they're relative to in the past, how significant they are, but you might see the northern lights." So when it comes to that stuff, I try to pass on only what I know and not spin it at all. Like it's
yeah,
okay to not know everything, but I don't want to be passing on bad information. You know?
exactly. And like, yeah, there's never that like intent to do so. But I mean, if you're just like trusting what the space weather predictions said, like even their thing was wrong. So it's like it's a win-win Or, sorry, it's a lose-lose. It's like, what do you do? And so essentially what I ended up doing for the second night, I was like, hey, we might see it. Like, here's how you look at it. We might see it after 7 o'clock. Go look at it.
Coin flip.
It's like all like everybody that can see me on TV. Like, it doesn't matter if you're on the north side of town or the south side of town. Like, you can see it. In fact, let me show you. Let me show you some of the pics. This is from Wednesday night, and Wednesday we had the combo of like the meteor shower and the aurora going on. And do you remember what the meteor shower is? You're the astronomy expert actually in this room.
Were these Illyrians?
I think I have it written down. Possibly.
I could be off.
Leonid.
Oh, yeah.
Leonid meteor shower. So that's kind of nice.
For as many of them as I know and I've covered, they're all like the basis of Latin. So I usually say one of them wrong. Like the Perseid meteor shower, I say every year, and I always say it wrong on the air, which makes me look like a moron. But
it's okay. There aren't a whole lot of Latin teachers out there watching you. This one I had to double check was like real. Because this one came in on the low energy night on Wednesday night. I had to go back and like check the flight schedule and the direction this plane was coming in, and it for the most part passed the sniff test. So I think it's legit.
Huh. I hate that we have to thumb through that sidebar because that is incredible. Should it be real?
Yeah, and I've seen
like it's hard to wrap your mind around that. That's literally that electromagnetic energy occurring, and you can see it looks like, unless my screen's just showing it, is it red above there? Is there like a different hue?
So essentially, we're looking at the plane of a southwest wing here, and the bottom half of the sky is all green, and the top half is pillars of red. The ones in the planes are always the coolest. And if you're listening to this podcast, I really encourage you to go and watch this one, or just look up Aurora from plane, and you'll see it's pretty intense.
Anything from a plane view. When we talked about those sprites, the red and blue sprites, those are seen often by high. What are they called? The military jets that go up to like 60,000 feet. They'll see them because they're so high up in the atmosphere, and they'll be these awesome colors. But man, to see that in person.
This is more, and I don't know if these are like all meteors or like Starlinks going across the sky there, but that's how Wednesday night started right there. And then I think this is like Tuesday night, and I think I'll just go for the best ones. But this one's cool. It has like lots of waves, like green waves going through with the red pillars. And the ones when you get like other people or like things in nature, and with the aurora pictures are really cool. Like this is a little girl loving it. You got the American flag. It happened on Veterans Day, so I got a lot of pictures of the aurora and the American flag. Velocity couplet there.
I'm about to say there's something about that doesn't just say Christmas.
This one is like a spaceship where you have the greens like wrapping around the red pillars coming in.
It's like a swirl. See, that's something else I would love to talk to somebody. I don't know. Maybe we can through our connections find somebody. You know, I'm not far from Huntsville. I can reach out to somebody I know there that might be able to join us. But I would love to know kind of what gives it that shape. Is it our position relative to where that is happening? Is it the pulse of energy that's coming through? Because some of those are pillars. That looks like a swirl, almost like, when there's motion within the atmosphere with a cloud.
Yeah.
I have so many questions about this, and this is just a great reminder that in this field, man, in geos, you get to learn when stuff happens, and to see something this cool this is awesome.
The pillars are more often than not red, and then the greens are more like fluid, from what I observed. Like reds again towards the top, a little fluid, a little tractor and wind vane, windmill.
Like that. Nothing says Kansas like a nice weather vane.
That definitely was a Kansas photo. And of course, you got a deer over here just hanging out.
Man, that looks like a desktop background.
And then I think that was it. Yeah, that was pretty much it. Those are some of the good ones overall.
I'm gonna reach out to There's a girl I know. She used to be a meteorologist up in Huntsville. She since stepped away from on air and was doing stuff with NASA in Huntsville. Maybe see if she can't find somebody because the more I look at those pictures. So you just gave a different perspective than my experience was. Ours was all this. We didn't have those greens. So there's obviously a factor in that why we didn't see that. Was it where we were from a latitude standpoint? I have more questions about other stuff now that we've seen the pictures, but no doubt, just really cool. Science is awesome,
Yeah,
except when you're taking chemistry and physics. Those suck.
I hate chemistry. Physics you have to do because like we do just there's so much physics. There's like fluid dynamics and
Oh,
thermodynamics, but chemistry can go.
here's what's crazy too.
Because
Those equations that look like a foreign language on the map. Once you start studying weather maps and atmospheric motion, it all clicks into place. The physics is how everything moves, and sometimes I use that to explain, like, hey, you ever seen, how if you were to go stand at the edge of a river, right, and everything in the atmosphere moves from west to east generally, and there's a big old log in the middle of the river. You don't want to get hit by the log. So you got to see where it is, how fast the water's moving, and is there anything that's going to cause that to deviate the path? And that's why we got to look at these patterns and all that motion. So everything together on those ridiculous looking equations that we had to memorize is just so we can understand the behavior of the planet and how it's changing second by second. So we're in the right field, I think, as
yeah,
weather nerds.
and we're always trying to learn, so that's helpful too.
Yeah, I encourage everybody to. We are not by any means, I feel like, on here to be like the smartest dude in the room. We just like talking about this stuff, and I'm really hopeful now about to maybe learn some more about this. Um, Question for you that's kind of changing the subject. Did you guys have any like record lows this week? I know the trough was focused a little further to the east than you guys, but I was just curious what your temperatures were early
No
this week.
record lows. Whenever I was watching these anomaly maps, I think I showed an anomaly map like for 5 nights in a row. There were higher anomalies or colder than average temperatures, like higher. What's the word here? It was colder than normal for you as compared to us.
Yeah.
So,
So if our average is 65, which it is, your average might be 58. So an anomaly for us will not be the same as it is for you. 58 for us would be an anomaly. 58 for you would be exactly what it's supposed to be. So it's all relative. This cold air aloft that came in was something we get in January. That was the
mhm.
intensity of it, and it absolutely um, did. So I love numbers, so I spent a good chunk of the day, going through XMA6, and there's over 200, I think 250 between ASOS, RAWs, METAR, and co-op stations across the state. And when I finally thumbed through it all, there were 57 records set, 57 different stations that represented 46 towns, 35 counties, and three were tied records. Birmingham was one of those that went back to 1926, so it was a 99-year record we tied, which is just it's crazy to think of that in the perspective of it because we're now back at 77 degrees. Um, that location there, Greensboro, today it had a high temperature of 77. It broke a 131-year record on Tuesday morning. Um,
Yeah, 18 is, I mean, I think 19 was our coldest temperature on Monday morning. So, man, that's very surprising that Greensboro. I wonder if this place was like in a valley or, I'm sure it maximized the cold air in some way, but that's still
so
really impressive.
that is part of the Black Belt. It is in that big kind of crescent shaped area that is very fertile. It's kind of like a continuation of over in the Delta, and it's in a river plain. So the
Okay.
Black Warrior River kind of snakes down that direction too. So that's actually normally one of our warmer spots. I would never have guessed that that was the location that was going to hit 18. That is never the coldest spot.
Hmm.
I would have guessed somewhere like Anniston, like Gadsden. Obviously, Scottsboro makes sense. Northeast of Birmingham, there's a lot of elevation change. But even Selma at 19, they're much further to the south. They're, and maybe that's just how everything settled that night. Is the coldest air just got in some spots because winds were dead calm after a windy day. But I mean, the whole state had a freeze. This ended our growing season, which normally happens this time of year anyway. But 28 Mobile, you could have been at Dolphin Island. It was 31. You couldn't escape this cold, and this is early for a cold air mass to this magnitude. So I love the numbers. I just thought I'd break that down. There was a couple of these records that were shattered. I mean, by 4, 5, 6 degrees. We set a record. It's like, oh, we beat it by a degree.
Yeah.
I mean, Dothan's record I think was 34. Geneva's was 29. So some of these were just big, big. It was cold.
Yeah, the biggest jump one. That's a good kind of breakout, if you will, for an 8 degree beat on the temperature is pretty incredible. It's like that's very rare. You usually are not breaking a temperature by that much.
No. Yeah, so like some of these 6 degrees, that's the Alabaster Shelby County Airport. So that's a 6 degree drop. The previous record there was 27. So there was so much to go through. I printed out XM-A6 and I highlighted some stuff because I didn't want to get it wrong. There's a lot to go through, but
Yeah.
that to me, it wasn't necessarily that we set records, it's how far we blew them away and some of the ones that we, beat. So this kind of ties into the Auroras, the Northern Lights. This was a record cold for us, but we're looking at this in a span period of record, I think goes back to like 1890. Not for all these stations in Alabama. So we're still looking at a relatively small, chunk window into time. And it'll be interesting to see when do we get another shot of cold air like this, because our pattern's completely flipped now. So file it away, learn something, and we'll get to see how a trough like this, can it move in early November. Anyway,
It may come back. You got the old negative NAO, negative AO setting up for December. You may get something again here soon.
I
We'll
hope
see.
so. I mean, actually makes me. So we talk a lot about how, there's cool things where something's happening on one side of the planet. We know it impacts the overall pattern. We just can't connect
Mm-hmm.
all the dots. It's like point A to point B. You know where it's there. There's something in between in translation that is lost. And I think teleconnections is a perfect example. A pressure change halfway across the world obviously causes a ripple effect, but it's figuring out when that's going to happen. It's figuring out how strong it's going to be, and then how significantly will it shift your pattern. A perfect example, Wes. I follow tropical season pretty closely because we're, part of our state is right along the coast. That
Mm-hmm.
Bermuda high, all the forecasts that were put out, you had no way of knowing how strong that Bermuda high was going to be and where it was going to be located, because that's what we call a semi-permanent feature. There's highs and lows around the world that are there most of the time. The Sahara Desert, semi-permanent high. Um, Bermuda, the Central Atlantic, semi-permanent high. You also up near Alaska, the Aleutian Low, that is there most of the time. There are these features that are there, but they pulse up, and when they do, they impact our patterns. They can make the East Coast really hot when they expand and move west. They can steer hurricanes away from the United States, and that's what they did this year. I think we had 4 major hurricanes ride the outer rim of this high pressure circulation, and if it was 200 miles further west, we have major hurricanes making landfall. So like these just connections, these everything that's in play is something to think about, and makes you wonder how the heck do we come up with forecasts long term. Be careful when you see these maps that are put out that say, hey, it's going to snow in Feb. Just careful, all right? It's like throwing at a big old dartboard, all right? There's not a ton of reliability in that stuff.
They just want you. They just want your clicks.
Yeah.
People,
So
there are accounts now just post long range snow maps, and like, and some of these account owners are finally acknowledging or like saying this is just a long range model. Things will change. It's like, dude, you just want the clicks, you just want their money. Like the want for money on Facebook has increased even more. So
yeah, it's
don't don't get too excited about a literal 30-day or 45-day snowfall
yes.
forecast.
So one of the reasons that's a good point you bring this up. That Wes and I wanted to do this was, and probably a lot of people don't find us interesting at all. That's okay, but we can put out information that's good. We get inundated with a lot. My grandmother's 80 years old, um, and they would text me periodically and say, "Hey, is there a hurricane coming to Fort Myers?" And I'm like, "What? Is there a hurricane on the way?" No, but there's information that's put out there that's just it's misinterpreted, and I think it's intentional. So we like to give context to stuff and discuss weather because it's a lot of fun. So Wes and I were talking about this before the show. I love to explain the weather when I'm forecasting, and this was kind of goes along the lines of how patterns can impact the going forecast, and it can change abruptly, and why long term forecasts are to be taken with a grain, a sample of salt, not all in. So this is a look at the upper air pattern next week. Wes, if you'll recall,
Okay.
this spring we had a ridge over the southeast, trough over the Rockies and southwest. And what did we have for a week straight? Severe weather from Shreveport through Fayetteville up into Peoria over to Indiana.
Okay.
We had this big ridge, and the reason I remember it is there were 6 straight days where there was at least an enhanced risk of severe weather to the west of us, but it never got to Alabama because we had a setup like this. It's not apples to apples, but when you see a high or a ridge intensify in one area of the atmosphere, that can cause a huge shift in our storm tracks. So the analysis I gave, or the analogy I should say, is you're driving down the interstate, right? And they've closed two of the lanes on the right hand side. So now all the traffic is being rerouted to the furthest left lane. Our storm systems, as they travel as synoptic systems, your low pressures, your cold fronts, everything associated with the jet stream, it wants to move from west to east. This is a blocking feature. There's your traffic jam. It causes all those systems to go up and over. We're going to see 7+ inches of rain possibly in parts of the Ozarks, northern Louisiana, northeast Texas, because the rain and the storms are not able to progress into central parts of the southeast. We're bone dry until maybe Friday because everything's going to go up and around this little feature right here and make us hot.
I was going to say by Thursday that trough comes through, and then we're in like maybe another several days of cool conditions. And of course, this is like the complete opposite of what like the CPC says. That's the funny thing.
Yeah.
I actually think that during this period we will be cooler than average.
I fully buy into the warmer than average. I've seen this enough. Is a very frustrating feature to forecast for, because anytime we're in that fall, winter, spring season, you'll get this ridge that sets up over the southeast, and there will be a temperature gradient west. It'll be 42 in Huntsville and 70 in Birmingham. It is insane how it sets up, and it's very hard to predict. But we'll get these periodically, and they'll last for however long they do, maybe a week or so. But I think it's going to hold. I think we're going to be warm through the end of November. I'm not going on the air and saying, "Oh, this is exactly going to happen," because things change. But I do think this particular setup could lead to that.
Well,
So
that makes sense for you. Like for your part of the country, yes, I can see that. I just think that they've drawn this area of above average temperatures too far north. Like, I think probably next Thursday, and what is next? I got like 3 monitors over here. Next Thursday is the 20th. Dude, I could have done that in my head. Why did I look that up? I think, yes, literally. I think the 20th and onward, actually, it becomes cooler.
Yeah, because what has, and I wish I have the actual, in motion of this in my show, but what ends up happening is the trough of this moves further to the east, gets to about Little Rock, and then the ridge continues into the mid-Atlantic. We never actually get to the cold side of this system. The jet stream never dips south of us
Mm-hmm.
after this next wave because you have this high that's there kind of pushing back. It's a battle of air masses, man. Warm to the south, cold to the north. They clash.
Tornadoes.
There you go. There's weather in a nutshell.
Tornadoes. Why are there tornadoes? Well, what happens is you get the warm weather from the south and the cold weather from the north, and then they start doing this.
And they do not get along well. No, they don't.
That's the 3rd grade answer right there that I like to think about.
So this picture is in honor of meteorologist Eric DeBroca, who is he's still probably licking his wounds. This is
Probably talking to his bird. He and his bird are probably just chilling right now.
Yeah, Woodstock he's a cool bird. I met him. This is a look at the Ohio River over Cincinnati in the morning. That is what happens at night when you've got water temperatures that are very different from outside. So this was a very cold morning in Cincinnati back at the end of August. We had a cold snap there where it dipped into the 40s. Well, your river temperature that time of year ran at about 74, give or take. So at night, you've got 44, 42 degree air moving over a relatively warm body of water. And you got this. I mean, I thought this was the coolest thing. I did a whole explainer on it for social because just nature's beautiful. That is awesome.
What kind of fog is that, Evan?
Radiation?
Radiation? Yeah. Yeah. Or advection?
Wrong. There's 4 different types. I know.
I was going to say, it might be advection fog.
Maybe it is. There's like 4 different types of fog. And
let's list them. Radiation.
Valley or orographic.
Okay. Advection.
And
steam.
Steam. That's the other one. Maybe this is steam.
There might be more than that.
There's a lot of, you get into the weeds.
7?
And there's all different, basically what you're looking at for the formation of fog is what area has the best potential of cooling to a dew point or to a number where there's no more room for water in the air. You get colder, water's like, see ya, we ain't going to be having any of that. So it condenses out as dew and whatnot. And so in this particular scenario, I mean, you look off in the distance, it almost looks like it's like smoke, like spilling over the banks.
There's actually 6 types of fog.
Oh, man.
Advection, radiation, upslope, which is what you said, steam, and this one I've never heard of before, frontal.
I have heard of that, yeah. We would sometimes get that in Dothan because of how high our moisture levels were because we're next to the Gulf. So we'd have this very odd, it was only in the wintertime or the transitional time. But I totally forgot about that. But
and then this is ice fog, but it's freezing
fog. Yeah. When people hear about that, they're like, oh my gosh, everything's going to instantly like have ice cling to it.
That's what it sounds like. Yeah, for sure.
It does. It's not
but no, it's fog that forms and then it freezes on stuff.
It freezes on things and such.
Well, okay, hold on. This does say ice fog. We don't ever deal with this. So that's why we are getting this wrong currently. Ice fog is composed of ice crystals instead of water droplets and forms an extremely cold Arctic air, -20 or colder.
Okay, so basically me and you need we need to go down to the South Pole to investigate this.
Yeah. Okay. Freezing fog and ice fog, different.
Interesting. Well, either way,
that is really cool. That is, I love that.
I picked this picture because I was over Cincinnati, which is where Eric DeBroca forecasts, and where Eric DeBroca did not win the competition, which just cracked me up. I texted him immediately.
He never responded to the email.
I
He
mean,
never.
I know, and I said, "Oh, look at him hiding behind Outlook," and I knew I lost too. But it was funnier to me that um, we came into his backyard, and of course, it's got to be Wes. This is
Got him.
why I said Wes knows weather. Um, I will say this: there is something to be said for your local Mets. Somebody asked me at the YMCA the other day, said, "What is the best app?" And I said, "That's a great question." I said, "Honestly, it really depends on your type of weather. Because if you are looking at an app for weather at the beach, it's junk. If you're looking
Oh,
at an app for weather in a valley or in the mountains, probably going to be junk because it doesn't have a way to interpret some of these microclimate features. We see it all the time here in central Alabama. Our temperature range at night can be 9, 10, 11 degrees across the DMA because there's different topography. Um, so on a clear, cool night with no wind, your app's going to do just fine. But if you have a weird situation or a weird setup, your local Met's probably going to see that first. I see it all the time with James. I'll see his numbers and I'll look at my numbers and I'm like, am I missing something? And almost always I am. There's something he saw because he's watched it that the data's not going to tell you and that an app's not going to tell you. So with that in mind, I would ask of the two of us, Wes, what the forecast is going to be for your location because he seems to have a knack for this sort of thing. I missed it by the most. This was one of those days. Did we have the low temperature? Was this like 11:59?
yeah. It was. I don't know if it was 11:59, but it was a evening low instead of a morning low. It was like a night low,
So
which yeah, I think we all looked at that for the most part.
yeah. So this is we had the same thing happen here, Wes, and I'm looking back. So I keep track of all my forecast sheets here,
Mhm.
and then if I've been within the 3 degree or not. I was so off on Sunday. I had let's see, when I initially did it, I had a high of a high of 65, no, 62 and a low of 55.
Okay.
But when you see it on a 7 day, it's not going to make any sense. We hit both of those numbers during the day, but it was neither the extreme. It ended up verifying at 39 and 67. So I missed the low by like 14 degrees.
Were you just doing the
Because,
7 a.m. temperature?
hmm?
Were you just like doing like the 7 a.m. and the 3
Yeah,
p.m. temperatures?
yeah.
Oh, okay.
So
Yeah.
I put the low temperature is like 55, and it was close to 60 Sunday morning. But by the nighttime on Sunday, because we went trunk or treating, it was
Mhm.
windy. It was about 39, 40 degrees. It was unbelievably cold. We just plummeted in the afternoon. So if you look at that from a numbers standpoint, it was way off. But it's just one of those weird days. But West got
Yeah, but like when someone is looking at the 7 day forecast or whatever y'all do, I mean, they see the low number, they're like, that's the morning.
yeah.
So no, I wouldn't. That's not that big of a deal. That
No,
happens.
but I think you're right. I think in terms of the 7 day, what we should have on there is, I view it as our low occurs this time of year now that we've shifted the daylight at 6 a.m. and our
Mhm.
high is usually between 2 and 3 because of daylight. So I like forecast based off of that. Here's your this will be your temperature at 6 a.m. This will be your temperature at 2:30 in the afternoon, type thing, and that's where it gets kind of confusing when your low temperature at 11 o'clock that night is 20 degrees colder than the temperature before the sun came up. Wild. Congratulations. You
Thank
have
you.
12 wins, and we have not allowed a guest to come onto our turf and take anything. So good defense
Uh,
there.
that's good. I look at this at at the hourlies like super meticulously 4 days in advance because we're part of this forecasting competition, and you sometimes have to pick what the 7 a.m. temperature is rather than the low. Or if the high occurs at midnight, that's like what your forecast high is. So I have to like be super meticulous with what I'm going through.
I bet that gives you a different like perspective of the day because you have to focus in so hardly on that or so specific.
Yeah, it does help, like just know the forecast overall better. Um, it doesn't really allow you to brush over fine details quite as much. And um, how can I'm trying to say this in a good way. The person that's been winning for the last 5 years, I am tied with them. So
I told Wes if he
I'm
starts
coming for
winning,
you.
he has to bring me with him, and I promise I'll get better. I'm very good at in Alabama. It's getting into other areas. I was really looking at how our numbers have panned out the last month and a half. Is a good reminder of why model data is not the answer. So we're super dry right now, Wes. Model highs and lows have been off. It is
Mm-hmm.
much warmer in the afternoon than any model suggests, and it's been much colder at night than any model suggests.
Hmm.
Lack of moisture, you, when that's gone, moisture retains heat. It also absorbs heat during the day. So when we have more moisture at the surface, we don't swing as dramatically. We went from
Yeah.
36 to 72 today in one of our locations.
That's what we've been doing. Yeah. Huge, which is crazy.
Soil moisture, just little things like that you'll pick up, as you go. And whenever we're dry here in Alabama, we see some crazy numbers.
My colleague Jeff, who's been forecasting here a lot longer than I have, it's when you're in a drought, when in doubt, leave it out. If you think there might be rain, but you're in a drought, probably best to either keep your chance of rain super low or leave it out.
So don't get people's hopes up.
Yes, and like there's no moisture to pull from the surface of the earth that would come up with the front. If the system isn't bringing a bunch of moisture with it, it's not going to have a bunch to pull from in the localized area.
Well, and that's our system next week is coming in. And it's already going to be weak because there's no upper air support. And I'm sorry, unless it taps into some of that Gulf moisture, which I think it will, there's nothing really at the surface. Pretty good drought going on in Alabama. So we'll get our rains eventually. Last year it was November. In 2019, I think maybe it was January. We always make it up. It just comes at different times each year.
I was looking to see where is Birmingham. Birmingham's a University of Alabama town, right?
Oh yeah. Well,
There's not.
I would
There's not
say
much.
if Auburn was winning more, you might hear from them, but they're
Yeah,
not. So like it's Alabama everywhere. But we are an hour away from Tuscaloosa.
yeah.
So much.
I was looking at Alabama's football schedule, but they play at home this weekend. Auburn plays in Auburn. What if we did? Or that's next week. Auburn has a
Yeah,
bye. I'm
Auburn's
trying to think of some like SEC
Thursday.
situation here.
So UAB is playing in Birmingham and Tuscaloosa. So what if I've already done the forecast for the football game. What if we do the kickoff temperature of the Alabama game, and you are going to be at the Mississippi State game, and the kickoff temperature of the State Missouri game? Um, I don't know how we can compare that, but we'll
Okay, so
both forecast for the kickoff temperature, and maybe I don't know how we'd be able to forecast for the final whistle because games go different lengths. But
what if we do like kickoff temperature?
okay,
Like, but we each have to forecast for like right. Like we'll each do Birmingham and Columbia.
yes, yeah.
All right. So kickoff is at 2:30 in Birmingham. Can we just say what do you want to do? 2 or 3?
I think anywhere within, I guess, that hour, right? Because sometimes your temperature will fluctuate. But I think I did 2 o'clock temperature when I
Okay.
did the graphic.
All right. We'll do 2 o'clock in Birmingham and 7 p.m. in Columbia. Saturday.
All right, writing that down. Actually, no, let's do 3 o'clock because that means it will have. We don't start till the half hour, and it probably the temperature at that point of day might still be warming. So we'll do 3 p.m. and 7 p.m.
Okay.
The 7 p.m. is tricky because that's the time of day where how fast are we cooling off? So that'll be
This will
fun.
be a challenge.
Good idea there.
All right. It's on.
This was fun. I just like talking weather. I hope you
Same.
guys out there enjoy this and want to interact and ask questions. I am going to follow up on that Aurora's question, see if we can't get to the bottom of this and maybe learn some more because this is the type of stuff that we can put out there is fun. Everybody can get something out of it. It's just cool. So
Yeah. Well, until next episode, and we decide if either one of us can forecast the other person's city a little bit better than the other.
Heck yeah, if you got a question, idea, send it our way. I'm Evan, he's Wes. We're the Wise Guys. Love, baby.